Let's now discuss the interference due to thin films and reflected light. Say if we are having a thin film, it may be a soap film of which on the two sides it is here, and there is a soap solution having thickness T and its refractive index is mu. When some light is incident normally onto it, approximately we consider it a near normal incidence. A part of light is reflected from the top surface of film, a part is refracted into it, and from the bottom surface also a part is reflected. Now, when the two beams which are reflected in case of almost near normal incidence, and when these reflected light beams are observed by some observer, or when the two light beams are detected by some detector, the interference in the two beams will take place, and the resulting intensity due to the superposition of the two will be observed. Here we can see if this beam 1 and this beam 2, which are reflected from the top and bottom surface of the film, initially these are combinedly incident in form of a single beam which are in same phase, but when the beam 1 is reflected from the top surface, due to the reflection from the boundary of denser medium, a path of lambda by 2 is added into it, or we can say a path difference of lambda by 2, a path lag of lambda by 2 is introduced in the path of beam 1, and beam 2 travels a distance t in the medium of refractive index mu, and it is reflected and coming out. As it is reflected from the boundary of air or a rare and medium, no path difference is introduced, but it travels an extra path 2t in the medium mu. So when it comes out, its additional path will be 2 mu t. In one of the previous sections we have studied, when a light wave enters into a denser medium, its equivalent path in free space can be written as mu t. So in this situation, these two waves are having their path lags lambda by 2 in beam 1 and 2 mu t in beam 2. So when the two will interfere, here we can write a reflected beam will have high intensity when observed. 1. If we talk about their path difference, here we can write path difference in reflected beams 1 and 2 is this delta we can write as 2 mu t minus lambda by 2, and we can write reflected beam will have high intensity 1, beams 1 and 2 will interfere constructively. This implies here we must have 2 mu t minus lambda by 2 must be equal to an integral multiple of lambda. Under this situation, the reflected beam will have high intensity because the two beams from top and bottom surface will interfere constructively. Similarly, observer will feel a very low intensity being reflected when the two beams will interfere destructively. So here we can also write that reflected beam will have low intensity when beams 1 and 2 will interfere destructively, and this will happen when 2 mu t minus lambda by 2 will be an integral multiple of 2n plus 1 lambda by 2, or we can also write it 2n minus 1 lambda by 2, that is corresponding to the path difference, which is an odd multiple of lambda by 2 when the waves interfere destructively. So these are the conditions we are going to use for high and low intensity in case of reflected light.